database, and it's really picking up, and it has a very wide adoption, very good documentation, and very well supported in terms of plenty of tutorials and videos and courses, you name it. They are so active and unbelievable. So it's a real contender and a real competitor of a relational database, a really serious competitor. And every version, it's getting even much more powerful in some cases than relational. In the latest release 4.2, they also support transactions, even distributed transaction that is spanning multiple nodes in a cluster. So this is very good development that will only boost further adoption of this technology. Okay, so let's open the box and see how it works. Discuss some of the examples, some of the features, and hopefully towards the end I want to discuss a little bit about the scalability and availability, how it is achieved in MongoDB. So I'll start with some introduction, move on to some, oh sorry, I'm not going to do this. I'm going to introduce how to use it in Java, because most of you are using Java. Also, we'll see the document design, although there is no schema as such, but there are some decisions to make in regards to using embedded subdocuments versus referenced documents. We will see how we do a read, a write, update, delete, and how to do aggregate queries. And there's one more point here I didn't put in the outline, is the sharding plus replication. These are two mechanisms used by MongoDB to handle a large-scale data set and also to improve performance and improve high availability. Okay, let us introduce what MongoDB is about. First of all, it is a document-oriented database. The data model is not a relational model. The data model is a document. So the whole database is made up of collections, and a collection, you can store in a collection, you can store a document. So these documents does not need to have an explicit schema. It's not like in a relational database. In a relational database, if you recall in your project, before you were able to insert, update, delete from tables in your database, you had to create the actual database, and you have to define the schema. That's what you have done in your ER diagram, and then hopefully generated your schema and created the database. In here in MongoDB, there is that step is not there. When I say not there, you don't explicitly create a schema of document that you will store. But schema is always there, of course. Every document has some kind of structure. The developers are aware of it, but database does not really care. And it will not enforce any schema. So you can put documents that have nothing to do with each other, or they have slightly different structure, database will accept it. Yeah. But in relational, you cannot do that, of course. Relational, every table has a very strict structure, and if you try to insert something that does not comply with the table structure, it will be rejected. And here, there is no such thing. This doesn't mean you put a collection and you start putting heterogeneous and non-related documents. That's not the point. The point here, there is a schema, but it is implicit. And it is developers are aware of it, applications are aware of it, but database kind of, it knows that there is a schema, but doesn't care about it, doesn't enforce it. So we call this schema-less. But just don't be fooled. As developer, you still need to be aware of some kind of schema that you will be developing against. I think this will be clearer when I show you some demos using Java with MongoDB. So in Java, you still have classes. They are well structured with well-defined attributes, and each attribute has data type. And then you can take those objects represented, instantiated in your Java program, and you can push them to a collection in your MongoDB database. But the good thing is these collections, they might have slightly different structure, and no problem. There is no issue with that. So for example, you might have a customer collection. You will store in their customers. And then maybe some customers, they don't have fax number. You don't need to mention it as one of the attributes in the document. Or maybe they don't have, let's say, they don't have somebody contact, they don't have a landline number. It's fine. You don't need to have a landline number. But in a relational database, you have to have all these columns, even if they are not applicable to everyone. You still have to have them in the schema. And if they are not applicable, and when you insert a record, you supply a null for those columns. Or if you don't supply null, you have to configure those columns to be default to null. When you insert and you don't provide them, they will be by default assigned null. But in a document-oriented, the document, those fields that are not relevant for that particular document instance, you just omit them. Don't even mention them. Yeah? And another example for you might have some of the customers, let's say, might have a residential address and postal address, or a business address and postal address. So if they have both, you can provide both addresses. If they only have one, only mention one. It doesn't really matter. It gives you that flexibility because the schema is not really enforced. So to summarize, there is some kind of common schema between the documents belonging to a collection, but they can have some slight variation from one document to another. That's in practice how it is done. So as I explained, it comes with a very rich query language, kind of. It's an API for querying documents and managing documents. Yes, please.
Are we recording?
Yes.
Okay, can we close the light, please?
Yeah, yes. Can somebody please switch off the light? Okay. Yes, please. Thank you. Okay, good. All right, so as I mentioned at the beginning, it is a serious alternatives to a relational model, and it's really picking up. So here is a document, those of you who are not familiar with MongoDB, here is an example document. So it is a JSON format where you just specify the attribute name, value. And the value could be a simple type, such as a string, integer, decimal, Boolean, simple types. An attribute could also store an array of strings or an array of objects. So in this case, I'm just storing in the authors an array of strings. Then in here, what I have, the publisher attribute is itself another document. So documents can embed other documents. So in a relational model, of course, this is totally not allowed. The normalization, if you do any normalization to your relational model, you will get rid of this, and you will divide this into multiple tables. For example, here, the book, in a relational model, we will have one entity for, let's say, one entity for book, and the book will have just these simple attributes. Even the authors will not be allowed to be stored in the book, because the first normalization form, every field must be atomic, not storing multiple values. And then basically you need to break down that into an author table. And this one will be publisher. let's say here you will have publisher, and then you start linking. Maybe author has many books, and books can be authored by many authors, and you have to create a bridge table and so on. You know the story. Or it could be even if you keep it simple, you can still see say a book can be written by multiple authors, and then you will have a foreign key here, author ID. No, this is not really. You need to have a bridge table because it's in this case it's many to many. You must have a bridge table. And in the publisher, it's okay. You don't need the bridge table. So a book, one book is published, let's say, by one publisher, just for simplicity. And in here, you will have, as a foreign key, you will have the publisher ID as a foreign key pointing to the publisher. So you will have at least, let's say, 4 tables to represent this document in a relational model. But in MongoDB, you just store it as an aggregate as it is. So MongoDB is known as an aggregate-oriented database. The aggregate comes from the fact, I think I explained this before, that in object-oriented modeling, the type of relationship you can have between classes are classified into association, aggregation, and composition. So when you are storing in MongoDB, for example, an aggregation means you have some kind of whole and part relationship. Let's say an example could be a car is a whole and is made up of engine and wheel. So this is an aggregation relationship. So the car aggregates an engine and aggregates wheels, one or multiple wheels, maybe 5 wheels. So what we have here, so here is the relationship. So for example, car kind of is made up of, and this is the symbol for aggregation. 2 things is we find in a car an engine, maybe 1-to-1, and we also find a wheel. So one car has many wheels. Yeah. So this is an aggregation, which means this class here is called the whole, and those are the parts. Yeah. Now, what document-oriented database allows us to do is to keep this aggregation as one unit, and you store it and manage it as one unit. But in a relational model, you cannot do this. You have to break it down into multiple tables and associate them with relationships, as you saw before. Now, the consequence of this in a MongoDB, if you store this as one unit, so in one operation, you can store the whole car, describing all the car itself, and describing the engine, the car engine, and describing the wheels, and you can put all in one document. One insert to create a car, and one read to read the car and all its components. Versus in relational database, each of them, let's suppose that at least each of them will have a table. So if we create one car, you will have multiple inserts. One insert in the car table, one insert in the engine table, and maybe multiple inserts in the wheels table. So this is what I mean by aggregation. So a MongoDB is an aggregate-oriented database, which means it supports storing the whole aggregate as one unit. Now, composition is just a stronger form of aggregation. So, for example, if I have here a building and a room, of course, a building aggregates one or many rooms. But the only difference is that the room cannot exist without the building. If the building is destroyed or something happened to it, the room will cease to exist. It cannot exist on its own. So this is a stronger form. In UML, we kind of capture this as a field diamond. Okay, but it's still a composition. Sorry, it's still an aggregation. So you can store this one. For example, if you want to describe a building, you can store the building and all the room details in one document. Yeah? In relational database, you have to break down this into multiple documents. So for example, let's say an organization, you describe, let's say an organization, how many rooms they have, whatever. And then each room you will have one record per room. But in case of MongoDB, you can store the whole thing as one document. So that's basically the idea of aggregate-oriented. So here is another example. So we have here a person, and we have a car. And a person has one or many cars. They own one or many cars. So in a relational database, you have to put this as two tables, and you have foreign key linking the car to the person. So there's a foreign key here, the owner ID, and you put the foreign key to link it with the owner. In MongoDB or in a document-oriented, you can store all this information in one document. So in here, the first part here is this is the owner. And here, this is an array cars. This is an array of cars. It's not mentioned here. We have to close the array. By the way, when we have an array, we delimit it with square brackets. And inside the array, you can have other objects. And objects are delimited by square brackets. Curly braces. Okay, and inside you have name value pair, name colon value, delimited by comma. So it's very, very simple data format known as JSON. And this format kind of is discovered or invented in JavaScript. And then it became so popular on the web. So it is a very, very popular data format for exchanging data between applications. Even within the same application, if you have multiple tiers, like the user interface, the business logic, the data access, so between your business logic and your presentation or your view, they communicate by exchanging JSON documents. Yeah, so let's say if you have a mobile application, and let's say a Facebook mobile application. So when you want to get all the updates or the posts of your friends, those could come to your mobile application as a JSON document, and then the mobile application will visualize them, let's say, as a list view within the mobile app. And when we create a new post, again, it will most likely the mobile app will create a JSON document, send it to the server, and the server will persist it. Now, the MongoDB, what it allows us to use this JSON format in all the layers, from the presentation layer all the way to the database layer. We use the same data format all along. Okay, so what MongoDB and a document-oriented database in general allows us to reduce what is known as impedance mismatch. We discussed this impedance mismatch, and if you remember, earlier we tried to address it using GPA. By using annotations, we try to bridge the gap between the database world and the object relational world by using annotation. But in here, this is another way of addressing the mismatch. If by basically in our application model, any aggregations, we keep them together and we can store them as one document. We don't need to spread them into multiple tables and then bring them back. And this is the famous example of order. So in an order, you have an order ID, you have a customer, and you have order items, and you have payment details related to that particular order. So usually in an application, let's say in Java application or C# or JavaScript, you will deal with an order as one unit, as one class. You have one class called order, and this class aggregates payments. It could be one or multiple payments, aggregates customer, and aggregates a list of order items. So if you are using a relational database, you have to have all these tables. When you create a new order, you have to insert into these multiple tables. And if you want to reproduce, let's say, an invoice, display an invoice to the user or provide them the ability to get an invoice, then you have to do a lot of joins to bring this information back into one unit. So it is costly in terms of development time and effort, and also in terms of performance, because you have to write complex joins. But in the case of a document-oriented database, you just take this object, whether it is Java object or C# object or Python object, you serialize it, you basically transform it to a JSON string, take that JSON string and push it to MongoDB, and that's it. In one line of code, you are done. Yeah? So that is the power of this. The power of document-oriented. And this way, you are avoiding this many inserts and avoiding this many joins and avoiding extensive complex queries to bridge the gap between the two worlds. So you just take the aggregate, object as it is, and you push it as one unit to your database. The other very important thing is that this becomes very much cluster friendly. What I mean here by cluster friendly, if you need to break this database into multiple shards or multiple parts, because your database grows, one server will not be able to manage it or to handle it. You can break your database into multiple partitions, multiple parts, and those parts could live on different servers. Yeah. So if you have something like this with tables and your data is scattered on multiple tables, it's much harder to partition your database into multiple partitions. Much, much harder. But if it is one unit, it's very easy to basically partition into multiple documents. You can even use some very naive one like the hashing that we saw last time. Yeah, the hashing. We can just have, let's say, remember we have a hash and we have a table like this. This table could be, let's imagine it is just, we have 4 servers, okay? 4 servers. Server 1, let's call it, yes, server 1, which is indicated as with the index 0. Server 2, server 3, and server 4. Yeah? Just as a naive one. All I do, I take the ID of my order, mod 4. Okay, and then wherever this mode 4, whatever this will give me, it will decide which server this document will be stored in. So this way, it's very, very easy for me to distribute these documents to multiple partitions. But this simple method cannot be, of course, applied when your data is scattered. So aggregate-oriented and document-oriented database are much, much easier to scale and much easier to partition into multiple servers compared to a relational model. A relational model much harder to scale, as I will discuss in future slides. Okay, now these documents, as I just mentioned, they are stored in collections. So you can think of a collection as a table, the equivalent of a table in a relational model, and a document the equivalent of a row in a table. So your collection can have multiple documents. These documents in real life will have similar schema, but not exact schema. And this schema, as I mentioned many times, is not enforced by the database. It's up to you what you put. So a collection is a group of documents, and it is anonymous or similar to a table, but the schema is not enforced. And documents in the collection have similar purpose and they might have slightly different schema, but overall they are so very similar. So you might have a collection for customers, a collection for products, a collection for orders, and so on. Okay. Now, once you create your database, you can, of course, start updating and querying it. Now, there is no SQL here. Like SQL is not supported by MongoDB, but they have very elegant, very simple API to query and update your documents. So let me just show you some small examples that I have been playing with. Here is one example here. Yeah, this is a small example what I had just to show you. So you can go ahead, download MongoDB. Also, when you download it and install it, it gives you the option of installing this MongoDB Compass. It's like an IDE for you to interactively explore your database documents and even query them. Okay, so what I have here, I have this people's collection, and in these people's collections I have person objects stored. So every document has an ID, underscore ID. This underscore ID is automatically added. When you insert a new document, this ID is auto added. It's called underscore ID. And in here what I have is the age, the name, and the city, and also I have an address here. No, this is some mistake where the city is here, but the city is supposed to be inside the address. I was just playing with some Java stuff and I added this attributes by mistake. But really this attribute should be part of the address object. So I have here person, and within a person I have an address, and with the address has street and city. Okay? Sorry, you had a question? Not really. Zoom in. Okay. No, it's good. Okay, good. All right. Okay, so what I can do here, although there is no schema, I kind of ask MongoDB to explore my collection and try to learn if there is some common schema. And it can go ahead and do so to help you understand your collection. So hopefully when this comes back, come on. Okay, while it's thinking, let me see this one. Here is another collection. I'll come back to the other one. Here's another collection. Again, these are restaurants. Restaurants has a name. There is a contact here, the phone and the email and the location. This is the GPS location. And I have the stars. These are like maybe the ratings, and this is the category. It's an array. Category of catering they are serving. Yeah. Now, this contact, similar things you can see here. Now, if I go to schema, yeah, you can see here, it showed me, all right, this is the object ID, the data type is object ID. Category is an array. it gives me a bit of indication. Minimum in the collection, the minimum number of the length of the array is 2 and the average is 3 and maximum is 4. So it gives me a bit of statistics about those attributes in my collection. I have a contact, which is another document embedded in my restaurant document. In contacts, I have email. These gives me some sample, or maybe this is exhaustive because I have only a small number of documents here. These are the values in this document, in this particular attribute. Location, because this is GPS locations, it went ahead and even showed them in a map. Okay. Now here is the phone. It gives me some sample data and so on. Yeah. Now stars is integer. Okay. 100% means 100% of the collections they have this stars as integer. But in other collections, although in practice you want to be consistent and always store the same data type in a particular attribute, but you are not forced to do so. There is no enforcement here. It's up to you what you want to store. And here it gives me some histogram of frequency. So I have 25% that have star 0, 30%, 40%, 50% have the value 3, and 25% have the value 4. Not only this, what this allows me to do, it also allows me to easily query. For example, I can, let me see, what is the category? Category. Yeah, here's the category. Here it gives me the possible values and their percentage of occurrence within the collection. And also it helps me to write my queries. So I can see, please give me the ones that serve steak and cake. You see here there's some filter that gets created. It helps me to write my queries. Should be able to select multiple. Yes, you can see here I'm looking for anyway. So I can take this. This is how the queries look like. So I have here a find. I will show you shortly. I am doing here a find operation. So I go to my collection and say, go ahead and find me the documents where the category is one of these categories, steak or sandwiches. I can take this filter. It's already copied anyway in here, and I can do find. And you can see here it went ahead and executed this query and gave me the documents where the categories is into these two categories. So this gives you already a taste of how the query looks like. So the way I write query, I do find, which is basically a method equivalent to select. And in here, this is the filter condition, equivalent to the where clause in a select statement in SQL. So in here, what I'm doing, categories is this categories attributes. I am asking the database, please only give me the categories where the value is in one of these values. Yeah, I can also go back here and say, also, I want the star rating to be, okay, let me go back here. I want also the star rating to be greater than 3 and less than or equal 5. Okay, let me try to put it in Notepad just to show you taste of how these queries look like. So in here, what I'm doing, you can see here this filter has two conditions. The first condition, category, is one of these. And the second condition is stars, greater than 3 and less than or equal 4. So this is how the queries look like. Okay, and if I run this, you can see here it gives me, you see here star 3, and the categories is one of these 2 categories I mentioned here. So this schema, not only it allows me to get an idea and get familiar with the kind of derived schema from the collection, from the documents in the collection, it also helps me to very nicely create queries, like kind of visually create the queries. Okay, so let me go back now to the slides and just give you some glimpse of how we add documents and update them and how we retrieve them back from our collection. So these operations are known as CRUD operations: create, read, update, and delete. So what we do is, database is just, this is referring to the database you are currently connecting to, and the collection is the name of the collection you are interacting with. And then here, if you want to add a new document, you just go to the collection and say insert, and you give here a JSON document. And it will go ahead and insert it. So save, kind of equivalent. And update. In update, what you do, you first put the where clause. This is you say update this document where this particular criteria that you put in the query the document that match the criteria you put in the query parameter will be updated. It becomes clearer as I give you some examples. For reading, so for inserting, we use insert, save, and update. For reading, we use find and find one. And for update, I use update. This is a bit repeated here. And for delete, I use remove. So we have basically, how many? 4 or 5 operations: insert, save, update, remove, find, and find one. Yeah. And in the parameters, you supply some parameters similar to what I showed you here. For example, this can go into parameter of query, and the parameter of the query is find me the documents where this condition matches. Okay, so let me show you some examples to make it clearer. So in here, what I'm doing, I'm going to the users collection and inserting a new object or a new document with these details, with the name, first name, last name, and age. As simple as this. This is for inserting. For updating, I have to, the first part of the update, I supply the condition to match the documents I want to update. So I might update a document with a particular ID, or I might update a document for a particular, let's say, give me the customers where the city is Doha. I can get them and then maybe update them. Maybe the phone number has changed. I take all the phone numbers and add 6 in front of them. If we need to expand, I think it happened once. If we need to expand the numbers, yeah. So you can think of this. We can think of it this way. You can do bulk updates. You can do single updates. It's based on the condition you put here. Now, when you want to just update particular attributes or particular not columns, particular attributes of the documents, you use this operation set, and then you open your curly brace and put the attribute colon value. So you can see here the API is very, very intuitive, very straightforward. Now there is another. So this is for adding, this is for updating, this is for finding. I go here and say, go ahead and find. If I just use user.find, it will give me all the documents in the collection. If I can also go ahead and say remove. When I say remove, I can pass in a condition. So in here, I am deleting all the users that start with J. And by the way, this condition here, this syntax I use for conditions of find is the same syntax I use for the condition of update and condition of remove. So once you learn how to create these conditions, which look very similar to what I just demonstrated here, then you can use them with update, you can use them with find, you can use them with remove. Okay. Yes, please. Okay. I will come to that. This is a general syntax. This is good question. Okay. Let me just a second. So this is This is kind of a native syntax. You can take this syntax and type it into this interactive Mongo, CMD. I go to the command line, I go for Mongo here. So this is an interactive shell. Let me see if I can increase the font. Properties, font. Yep. So this is interactive shell. I can say use, let's say restaurants, yes? Restaurant DB. Switch the restaurant DB. I will say show collections. Show collections. It will show me the collections. There is only one collection, which is the restaurants. So if I do here DB, maybe this is the way I do it. Restaurants collection dot find. It gives me all the, yeah. So this is db.restaurant.find. So this is the native syntax, the native query syntax. Now MongoDB, they did great work. In every language, there is a library that helps you to interact with MongoDB. If you learn the basic syntax of querying, inserting, updating, that syntax somehow makes its way and surfaces in the API of your favorite language. But slightly different, not slightly different, but basically tries to adapt the nature of that language. So it's not too strange. So you have a library to interact with Mongo in Java, for example, in C#, in .NET, in JavaScript, Python, and so on. So we will see shortly JavaScript in Java how it looks like. So in here, let me just give it a try. If I do here restaurants, if you remember what was the categories, yes? Just to give it a try. Close the curly brace, yes. Let me try, maybe single quote. Yep, you can see here, I made this query here, restaurants find, give me the restaurants where one of the categories they serve, one of the categories of food they serve is steak, and I get the restaurant. Yeah. Yes, please.
If you want to add a new entry, there's absolutely no constraints.
Absolutely no constraints.
So even the name attribute, we can ignore it, just add whatever we want.
Yes. Let's go here. Okay, just a second. If I go here, I'll do it from, let's go to here. This is people. Okay, Let me edit this one. I just want to see the row. I hope I can just get the row. Is there a way I can get the raw data? What I mean, let's go to here, for example. I come here and say add. Where is add? Is there any add? Okay, I'm not able to do it. So what I mean here, I can delete the whole thing. Okay, let me see what I can do. No, sorry, I want to. No, I just want to demonstrate that there is no really a schema. No schema is enforced whatsoever. There's no such thing as enforcement of schema in MongoDB. In fact, I can take this person object and add it to the restaurants object. Database does not really care.
Only ID.
Sorry?
Only the ID.
The ID is auto-generated. Auto-generated, yes. The ID is, you don't even need to worry about it. Once you insert a document, the ID is auto-created. Yeah. Okay, so back to here. This is just to give you some taste of how the queries look like. So here it is. In database, if I want to create a user, for example, I first need to create the table and define the schema of the table using something like this. Create table and define the attributes, define the data type, define the constraints. For example, ID here cannot be null, and so on. In MongoDB, all I do, I go to a collection, db.users.insert, and start defining my documents. The instance, I mean, not the schema, just the instance. Here, user ID ABC123, age, status. I go ahead and insert. If I do this, automatically this collection will be created if it's not there. Yeah, or I can create the collection myself explicitly. Let's see if we can do this. I haven't tried it, but let's give it a try. So what it says there, db.users.insert, and then I start defining my my object. So the object is basically, let me see, do we need to put, no need. So user ID 123, name, age. Okay, let's try. MongoDB, all right, inserted one. Okay, inserted one. So if I say here show collections, you have two collections. Yeah. If I do db.users.find, db, yep. The new collection. A new collection is created. A new document inside that collection is created, and the ID is auto-assigned. Yeah, no need to create any schema. In fact, if there is no collection, the first document you create, it will create the collection. Now, no schema enforced. Just let us do it one more time. In here, I can put here restaurant ID. Oh, sorry. something like this, okay? No problem. I can go ahead and see db.users.find, and I get both objects. It doesn't care. Of course, in practice, you won't do this. It doesn't make lots of sense. Because once you put heterogeneous collections, you cannot really query them in a meaningful way. Yeah. So you can put documents that are closely related. They can have slightly different schema. It's fine. Some fields extra in some documents, and missing in others. Extra subdocuments in some documents. So slightly different schema is very good. You take advantage of that flexibility to make your life easier. You don't take that advantage of that flexibility to do nonsense. Yes, please.
What's the help with the inheritance?
Can help with inheritance.
Because there was relational doesn't support inheritance natively.
Yes. So basically in here, it is schema-less. So whenever you have that flexibility and that freedom, you have to be responsible on how to use it to your advantage.
On the application side.
On the application side, yes. As a developer, yes. On the application side, you need to be aware of that. Plus, remember, this is a database. You can do indexing on columns. You take advantage of the index if those columns are common, of course, in the collection. So there is still, that's why I said there is still an implicit schema. It's just the database does not enforce it. But it is a good practice to have a schema because in your application, as a developer, you will have a schema because you will be dealing with an object model. You will be dealing with a class hierarchy, set of classes that you already created. You want that flexibility, but still you want the schema to be still there. Yes?
Doctor, can I enforce some attributes to be
Yes.
mandatory?
Very good. Yes, you can. There are some rules. I haven't explored this one myself, but let me quickly show you. Sorry. You can do validation rules. And when you define your collection, you can see here MongoDB. We just try to see some quick example. MongoDB collection validation example. Okay, validation. Just to get a glimpse of it. Okay, here it is. Here it is. Yeah. So you can see here whatever validator and date of birth greater than 1994, or phone is string, email is a string. So you can put some validation rules if you wish. So these will be enforced by the database. So if some columns are mandatory, you can put them as mandatory. But this is not a schema as such. Yeah. So for example here, version exists, false. In version 1, name exists is true. It is even more advanced because the collections of documents, you might have versions. So you had some implicit schema and that schema was migrated. And you have version numbers. So for every document, you have a version number. You can even say here, for version number 1, documents with version number 1, the name must exist. It is a must. It is a mandatory attributes. In version 2, name and type. Version 2 and type should be equal to or something like this. So there is, you can define validation rules, definitely. Maybe this is not the best example, but here is another one, just to see another example. Yep. Yes, you can see here, I am kind of defining a schema if I wish. Properties, type, and so on. Patterns, even I hear patterns. Required. Can you see here required? And I can put required field. It's kind of schema if you are starting to define schema. So you see here, like there you are teaching the database how to do it if you wish. It allows you to do that. You can even go to the level of defining schema if you wish. But out of the box, by default, there is no validation, no schema enforced. But you can define one if you wish. Okay? That's it. All right. Any question? Okay, let's move on. So as I mentioned, just by the fact of inserting the first document in a collection, if that collection does not exist, it will be auto-created. Or you can create a collection explicitly by saying db.createCollection. You can drop a collection by going to the collection name.drop, similar to drop table in SQL. Now for inserting, I already showed you this. You can insert one document at a time, or you can insert a list of documents at one go by just putting them in basically an array of documents. You can insert multiple at one go. Okay, so there is an example here. I have multiple documents delimited by curly brace, and I take them and insert them in one insert statement. You can also do it, if you wish, you can also do it by doing some bulk insert in memory and then executing that bulk insert. But this one is much easier. Just build your array of objects that you want to insert and finally push them all in one operation. So you can see here it's much more flexible even than SQL. It's true, it's not standard, it's MongoDB specific, but it's very, very intuitive and very easy to learn. Okay, so for removing, as I explained, removing, you go to the collection, you say .remove, and in here you put your condition. And this condition, the good news, the syntax you used here is exactly the same syntax you use with find. Exact syntax. So this will delete all users with the status D. The equivalent in SQL is this. If you do users.remove, it will remove all the documents in that particular collection. For updates, as I explained before, it has two parts. This is the query part. This filters the documents that will be subject to update. And then in here, I go and say set. This is an operator in the MongoDB query language, set, and I set the status to A. And this is the update option. If you don't specify multiple true, then only the first matching document will be updated. So you do multi-true, and then all the matching documents matching this particular query, which is basically taking users with the age greater than 18 and changing the status to A, and updating all these users in one go. And the equivalent of this in SQL will be something like this. Yes, please.
And can we delete a specific attribute instead of deleting the whole object?
Instead of deleting the whole object, deleting a particular attribute. Yes, I think so. I haven't played with it, but I guess there must be some kind of remove, or I haven't played with it, but I'm sure it's very, very flexible. Remove an attribute from document MongoDB. Yes, and set. Most likely and set will do it. Yeah, you have set and set. That will remove it. So definitely you can do that, yes. Very flexible. By the way, you can even go to an array. I didn't put here comprehensive all the capabilities. You can go to an array belonging to a document and push one extra element to the array. The update could be very fine-grained. Yeah, you can target a particular attribute and change it the way you see fit. In here, I just showed you the basics. Okay, here is an update. So in here, I am updating the inventory, the document with the item ID, and I'm setting two things, setting the category and setting the details. Also, I am setting the last modified date to the current date. So set is one operation that comes with the MongoDB to update particular attributes of the document. And current date is basically asking MongoDB, go ahead, take the current date and paste and assign it to the last modified date attribute. Okay. In here, if I don't specify the set operation and I do an update, what will happen is this new object that I specify after the query will replace my document. So I can take a new document and replace an existing one if I don't put the set operation in front of it. So this way I am replacing the actual document. So in here I am updating a particular attributes, and in here I am replacing the whole document. Okay. Now in here what I am doing, I'm not sure if the document exists or not exists, or maybe I am doing an update. And this is very common. Those of you doing development, we always face this. If we want to have, typically we have forms to update, to add and update. And those forms are very similar, except in add. In add, they are empty, the fields are empty, and the user have to enter the details. And then we go ahead, we collect the data that the user entered, and we push it to the database. In the relational database, we use an insert statement. And then if the user is updating, we bring the form, we fill the form fields with the data that previously was recorded in the database, allow the user to change the data, and then we collect whatever the user have entered, and we push it to the database using an update. And we have to do two statements, and we have to worry about doing it twice. Insert and update. Very different syntax. In here, two birds, one stone. So what I'm doing here, I'm really doing an update. Go ahead and try to update the document with this, where the item is equal this value. Replace it with this new document. And by the way, if the document is not there, create it. So I'm doing here two statements in one. I'm doing an update, and if the document is not there, it will be created. This is a really time saver, especially those of you who are familiar with little bit experience with development. You always face this scenario where you want to do an insert and an update. And in relational, you have to do it twice. You develop it. You basically develop two queries, one for insert and one for update. With MongoDB, you can do it in one go. This one will update if the document exists. Otherwise, it will insert new one. But don't forget to put this upsert as an option. Otherwise, it will only update. Okay, this gives you a glimpse of the query capabilities, the update, insert, delete that MongoDB is capable of doing. Okay, now moving on to query language. Let me just giving you a little bit more details and more examples. So in here, this is how I query my collections. I go ahead. This is my collection name .find and put my condition. And the condition is nothing. You can think of it. The condition itself is document, is a JSON document. So it starts and ends with a curly brace. And inside, it's a name colon, either value or yet another document. So the query itself, the query condition is itself a document. You can see here, it starts with curly brace. Let me change the color. Starts and ends with curly brace. And then here is the attribute I'm searching. am basing my search upon. This is the search query, the search key, and this one, it could be a simple value. If I don't put this, I could be a simple value, 20. This will give me the people or the users where the age is 20. But if it is a complex condition, I put it in another curly brace and put one of the operators that comes with MongoDB. Greater than or equal, less than, and so on. In, if it's an array, I do $in. Yeah. So this is fine, and I can sort. Again, the sorting, I can sort by multiple columns or multiple attributes. Sorry, no columns here. By multiple attributes. And all I do, I put a curly brace again and put the name of the column, colon, either one or I think one or maybe zero. One for meaning ascending order from the small to the high. Yeah, that's the idea. Okay, yes, clear? Okay, find, there is another one here. So in here I'm doing find with the complex condition, an AND condition. So in here I'm saying, here I'm not doing a complex condition. What I'm doing here, I am doing this is my condition. The age must be greater than 18, and I'm not interested to see all the columns. I am only wanting to get the name and the address. I don't want to see the other ones. So that's how you do it. This is one is include this column in the result. And the address one means include this column in the result. Okay, the ID is automatically included. So in my results, I will only have name and address. Okay, so let's try it here. If I quickly go here, people, and I'll do age, (45) as an example. Find is age 45. Then project. I only want to have the name 1 and city 1. Find. See here, only gives me the name and the city. The ID is always included, but if I don't want to include it, I'll do underscore ID 0. Find. It's gone. The ID is gone. So that's how I project. So you can see here the where clause, the where condition, the filter is an object. I open a curly brace and start defining an object inside my filter. The object will be the name of the attribute, colon value. And even the projection. The projection means the columns that will be part of the result set or the results. I put again the name of the attribute, 1 to show it, and 0 not to show it, to hide it. Yeah. Okay. Let me try to put here. So this is complex condition, greater than or equal, and I put here, let's say 20. Okay. Find. So all those are greater than or equal to 20. Let's confirm by putting age 1. So the age will be included in the result. Yes. Okay. And then the sort, what I can do here, sort age 1. And then they will be sorted by age in ascending order. Let me see if I want descending. Is it -1 or 0? I'm not sure. Yes, -1. They are sorted in descending order. It's very straightforward. So all the kind of the parts of the query is a JSON object. It starts with curly brace, and inside there I define either my filter or the columns I want to include, 1 to show it and 0 to hide it, to exclude it from the results. And the sort, it's also an object. I put the name of the attribute I want to use for sorting, 1 for ascending order, and -1 for descending order. So that is the capabilities.
Limit and skip.
Okay, limit. Limit is how many you want to get.
Like
Yeah, I want to get only 3 or 4. Let me see if it's supported here. Maximum item,
limit.
2. There's a limit? Oh, sorry, yes, there's a limit. So I want to get only 2. Here I get 3. 2, only 2, yeah? By the way, when you get this query here nicely, you can generate export to a language. Python, this is how it looks like. It's very, very similar in Python. This is a native query. I can take this query and run it natively against MongoDB, even using the Mongo shell. If I want to run it against using Python API, Python library, MongoDB Python library, I will be executing some query against MongoDB, and this is my query. It's very, very similar. Yeah, but except in here, the attributes now are in single quote. In Java, this is in Java how it looks like. I will do this. There is a function in Java. I'll show you later on. Greater than or equal, and I put the name of the attribute, colon, the value. And in C#, it's more complicated as usual. Node. This is JavaScript. Yeah. So very similar. Once you learn it, you learn the native one, you can easily do the other languages. Okay. So we'll continue another 10 minutes and then we'll take a small break. Okay, so here is the, yes, I already showed you this. This is the exclusion. If I want to exclude a particular value, a particular column, I mention the name of the column with 0 to exclude it. Okay. Find, I already showed you this. Find, you can just put find without any parameters or find with an empty object. They are equivalent. This is selecting everything or returning everything from the collection. This one, it's looking up an array. I'm saying, give me the inventory documents where the type is one of these types, either food or snack. So I use this operator in. This is similar in SQL. We put type in and we put the possible values. With and or. So if I just put them like this, the way we have seen so far, the conditions are connected by and. See here in this query, I want to get the inventory where the type is food and the price is less than 9.95. But if I want the or, I have to explicitly use the or operator. And in the or operator, I give it an array. And inside the array, I have 2 objects. Yeah? The first object is the first condition. So I want the inventory where the quantity is greater than 100 or the price is less than 9.95. So with the or, I have to use the or operator. Yeah? Okay. Now, if I want to do and or, no problem. You can do and or. In here, I'm saying, okay, give me the inventory documents where the type is food or the quantity is greater than 100 or the price. No, sorry. This is and. This is and. Yes, comma is and, yes. The or are basically these 2 conditions. So it must be type food and either of these conditions is true. Okay. Okay, so let me explain this one more time. So by default, remember the find operation takes as an input an object. In Java, in JSON, an object is delimited by colon. by curly braces. And an object is nothing but name colon value. For example, if I put here type colon food, and then here price 200. This will give me the inventory documents where the type is food and the price is equal to 200. Yes? So the objects, the attributes I put in the object that I pass as a parameter to find, these two conditions are connected with AND. If I want to connect them with OR, I have to explicitly use the $OR operator. And the $OR operator is an array. And what do I put in this side the array? The two conditions. Each condition is an object. So in here what I have the first object, which anything inside this object will be connected with AND. So this is my first condition, the type is food, and this second condition. The second condition happens to be an OR. So an OR is an element OR, which is the value of this element is an array. And what is inside this array? Two objects representing two conditions. The first object you see here is delimited by curly brace. This is my first object. And this is my second object. Yes? That's all. So in here, when the value is a simple value, I can just put it as colon value. But when the value is complex, it becomes an object. And inside here, I can put, for example, an operator, greater than or equal, colon 10. So this will mean that the price should be greater than or equal 10. So that's how I construct my query. Is clear? Okay. So queries, we will see this in programming when you are doing like Java or C# and so on, because the query can return you so many results, so many documents. So it's not a good idea to get all the results and put them in a list, for example. It might not fit. It might consume all your memory. So instead, what MongoDB gives you, it gives you a cursor. Those of you familiar with Oracle, they have this cursor kind of export to developers. And then you can iterate through the results iteratively. So instead of getting the whole result in one go, you get them in batches. Okay, so this is how you typically do it. So you will do some kind of find, and then for each batch or for each document coming back, you go ahead and do whatever you want to do with it. You process each document at a time. I'll show you this when I give you the demonstration for Java, how it is done, okay? So usually you don't get all the results in as one list. That is okay if you have a small number of documents. But if you get a large number of documents, that can put some burden on your memory of the client. So instead, you get a cursor and then you can loop through it and iterate through it and get one document at a time and do whatever you wish to do with it, without storing all the documents first as a recipient of the results. Okay, querying complex types. Because we have complex documents, the queries can be also very complex. So let me give you some taste of this. So in here, what I have is, I have these three documents. And what I'm doing here, find me the rating, or find me the inventory where the rating is 5, 8, and 9, which will only match this first document. I want the rating to be exactly like this. Otherwise, don't return it to me. That's one way of doing it. But another way, I just want to give me all the documents where 5 is mentioned in one of them, is one of the values of the array. All I do, the rating is 5, and this will match all of them because each of them has a value 5 appears as one of the elements of the array. Another one here, interesting one. I want you to give me the documents where the first element of the array is 5. So all I do, I go to that particular column, I keep repeating column, that particular attribute, and I'll say, go to the index, the first index, index 0, and it should be 5. Otherwise, don't give it to me. So this will match these two documents, but not this one. So you can go to that level of details when you're creating your query. Here is another example here. What I am saying here, give me the rating, give me the documents where the rating is greater than 5 and less than 9. Greater than 5, and less than 9. So this is greater than 5. Any of them that matches this condition will be part of the results. Okay, there is another one here. If I have a sub-document, can you see here, this is the name and this is an address and there is a state. And I want to get let's say the users that live in California. All I do, I will say persons.find. I look up the address.state equal CA. So I can basically go down and query using the sub-documents attributes. Yes? So here, that's what's going on here. So I use the dot notation to even access the sub-document attributes and do query based on the sub-document attribute. I can also do queries on, more queries on arrays. Let me give you some examples. So in here, what I want is, I want you to give me the inventory where the memos array, you can see here the memos array. I want the memos array where the memo text is on time and it's created by shipping department. So this will give me all the documents where, for example, this will be returned and this will not be returned. Yeah, because this one has memo, the text is on time and by is shipping. But this one I have on time, but it's by payment, so it will not be returned. So to that level, you can even query sub-documents. You can query arrays of sub-documents that you have there. Okay, so these are the operators that we have been using so far: equal, greater than or equal, less than, in, not equal. You can use all these operators. So for example, in here, I'm getting, give me all the inventory entries where the quantity is greater than or equal 20. In here, I'm getting where carrier.fee. So carrier is a sub-document. And I go to an attribute in that sub-document and apply this condition. And here, what I'm doing an update, setting the price to $9.99. Okay, so let us stop here and for 10 minutes. When we get back, inshallah, we'll talk about collection modeling. Although there is no schema, but the relationships between collections is still very relevant and very important. And in here we have two choices, either embedding versus referencing. So we will have a discussion when to use embedding, when to use referencing, and give you some examples of both. So let's resume at 6:50, please. Okay, thank you. So let me resume this. So let me show you first the data model, the class model. So I have here a class person. It has 4 attributes: the ID, the name, the age, and the address. The address itself is an object of type address. And these are the attributes of the address: the street and the city. Now, there is nothing special about this class except in the ID. The ID is of type object ID, to be able to match it with the underscore ID that MongoDB creates. That's the only difference, a noticeable difference. So instead of having the ID as int or as a string, we make the ID as an object ID. So the MongoDB, the driver, the MongoDB library, the Java MongoDB library will be able to match these attributes of the class with the underscore ID attributes in the document. Okay, so for me to be able to read and write to MongoDB, I need to add this library called MongoDB driver. The latest version is 3.11. You just download it, refer to it in your Java program, and then what you do is in your main, you create a MongoDB client. You create a MongoDB client. Don't worry about this stuff, you can just keep it simple. All you do is create. Okay? Or you can just go and say, keep it super simple. Just say new MongoDB client. Cannot instantiate. Yep. I did it on here. Mongo client. So here it is. Mongo client. Can't instantiate. That's fine. That's another way of doing it. So I create this instance Mongo client. This is the root object that I will use to connect. In here, by default, if I don't specify any parameters, I could put here a connection string. Can you see here a connection string that specify the server name, username and password, and so on? If I don't specify anything, it will by default connect to localhost, and the port is 1727, I think, 1727. That is the default port. So similar to this. This one is connecting to localhost 27017, sorry, that's the port number. So by default, if I don't put any connection string, it will connect to the localhost. Then what I'm doing here, this is one line that is a little bit cryptic. This is the only line that is a bit not so clear. What I'm doing here, I am going ahead and creating a Peugeot codec registry. What this Peugeot codec registry is doing, you know how I have normal Java classes and I have documents. Yeah. So when I query the database, what I will get back? Documents. But in my program, I am dealing with what? Objects. So in one side I have objects, in the other side I have documents. And what I want this Mongo client to automatically convert documents into objects and vice versa, as long as they have exactly the same name. So it will do the matching by name. So for example, here in person, take a look at this. In person, I have ID, name, age, address, and then within the address, I have the street and the city. If I go to the document library, not the document library, sorry, MongoDB collection, if I can get rid of this. Escape, oh, thank you. Okay, so if I come here, reset, you can see here exactly the same age, name. This one I added later, but address is the city and the street. Okay, so exactly the same. As long as I have exactly the same, I should be fine. Also, the ID, the underscore ID, the column or the attributes I want to map to underscore ID, it must be called, I think it must be called ID, and the data type must be object ID. Yeah. So later on I rename this just to confirm, but I think it's, for us, let's keep it safe until I confirm. The name of the column is ID, the name of the attribute is ID, and more importantly, the data type is object ID. Yeah. So now how do I tell, oh, please MongoDB, try to help me MongoDB, the client, the Java client, try to help me map documents to objects. I create this codec registry. It's built in. You just copy paste this code. I'm Mongo client setting get default codec registry. This is the default. You can have your own custom codec in the sense that you can add some annotations and map your attribute names that are in the classes that are slightly different than attribute names in your document. So if they are different, you might need to create your own codec or your own mapper. It's just the naming here, they choose very quite cryptic, not so good naming. All this line is trying to do is just to try to tell the job or the MongoDB library, please, when you go to this database and try to read and write to it, please use Peugeot codec registry. By the way, Peugeot stands for plain old Java objects. It's just normal Java classes and Java objects. I want you to go ahead and map them to documents automatically. Okay, once you do this, you go from the Mongo clients. The Mongo clients, when you create it, you already connected to the database. And you say, please go to this database called MyDB and give me kind of a reference to it or a connection to it. Once I get my database connection, I'll go to the database and say, please give me the collection called people. And then, by the way, the documents in that people collection should be mapped to the person class because they have the same schema. Yeah. So that's why I told you collections, although they don't have explicit schema that you define in the database, but when you are dealing with them programmatically, they have a schema. In this case, the documents stored in the people's collection are mapped to Java class person. Yeah. Once I do this setup, which is getting a Mongo client, using that Mongo client to get a connection to a particular database. Yes, if it's not there, it will get created. That's what I did. I didn't create this MyDB myself. First time I run this, it gets created. Yeah. Okay, so from the database, I say, please go ahead and get me this particular collection and map it to this class. And that's it. Once I do this, I go to this people collection. I just drop. Drop means like delete all the data that is there and start from scratch. So, and I start creating an instance of an object. This is how we create an instance. You're already familiar with this. New person, and this is the name, this is the edge, this is the address. So I create an instance. Once I create an instance, I go to the collection and say insert one and give it that instance. That's it. This will push it and create a document inside that collection. So the object will be converted to a JSON document and pushed to the database, to the collection, in this case, the people collection. Not only this, remember, when I push a new object, it will be automatically assigned a new underscore ID. And that new underscore ID will come back and will be assigned to the ID attributes. So if I do lookup, if I say people collection dot find dot first, which will give me back Ali's details, then I will see Ali's details plus the ID that was generated. Okay. Now I can also do a bulk insert. So here I'm creating a list of objects, and then taking that list and basically pushing it in one go to the collection. Collection insert many. So in here I said insert one, and in here I'm saying insert many. And then that's it. Push all the lists in one go. Notice here, take a look at this. When I am when I did find.first, I get an object of type person. The document was automatically deserialized and converted to an object. So I have an object. I only deal with objects. So when I am pushing to the database, I push an object. When I'm getting back from the database, I get an object. And this, what they call codec, Projo codec registry, is the one doing this conversion from document to object and from object to document. Yeah. Okay, so let me show you another one here.
Sorry,
Yes, please.
The name of the attribute, like age, or from where it is.
The name, so from the schema from the attributes of the class.
If it wasn't created, so it will, what name?
So, which schema you mean? Like,
Oh, so
because database does not have a schema.
get the age.
Yeah. So what we have here, we create a class like normal Java class, create an instance of the class, and push that instance, which is an object, push it to the collection. And that's it. It gets created. The names we have here are the names that will be created. I mean the attribute names of the document that will be created in the collection. Yes, please.
But this way we need to put all the attributes in the database. Is there any way to have like optional input? Because you said
Yes, there is. There are some annotations. I didn't go through them. When I post this example, I will add some annotation. There are some annotations. This is kind of the basic. There are some annotations that come with this MongoDB client library. You can add some annotation to further customize the mapping between the objects or the classes and your document. And definitely, I'm 100% sure they will have the ability to have optional attributes. Yeah? Okay. You can even rename columns, rename attribute to different attribute names in the documents if you wish. So you can do mapping similar to, if you remember JPA, kind of similar. You can have those mappings. But if you don't put any mapping, this will still work out of the box. You can still further customize this through further mappings.
is there an automatic mapper like we did in the previous stage?
They could be. I haven't explored this one.
We make all the classes.
No, you already have, for example, in your project, you already have all your classes. You're not changing anything in your project. All you're changing is the repository. You will have two repositories. One you already did that will talk to a relational, and you will implement another repository that will do exactly the same use cases and the same capabilities and functionality, but this time using MongoDB. So you will be reusing exactly the same model that you created before. You are just using MongoDB instead of your relational database. Okay. All right. So moving on. So in here, if I want to get the total of number of documents in my collection, all I do, I go collection dot get document count documents. This will give me the number of documents in my collection. Now here, in this line here, what I'm doing, I'm going to the collection and say find. What this will do, it will give me all the documents. They could be thousands or even millions. So I need to be very careful. In here, I don't get a list because maybe in my client, the memory will not be able to handle all the documents coming back from the database. That's why I get a find iterable. That I basically take this and keep looping and getting one document at a time. So this way, I don't need to load all documents in one list and then process them. I can if I wish. I mean, I can do this dot to list. I think into and I convert it to a list. I can convert it to a list if needed, but it's better to just leave it as it is and loop through it and get and process one document at a time, whatever you wish to do with it. Okay, so now if you recall, the find in the native query that is supported by MongoDB. We can query and put our query condition in here. So what I'm putting here, find me all the documents where the address.city, this is an attribute of a subdocument, equal Doha. And I only want to get back the first one. So this is similar in the native, if you remember the native query, this will be written something like this. Address will be written something like this. Curly brace here, and natively it will be written like this. This is how it will be written. In Java, it will be written this way. So I put here equality, equal operator, and I want you to get me only the documents where the city is equal to Doha. And I'm not interested in all of them, only interested in the first one. It will go ahead and get the document and auto-convert it to a person. You see this somebody here, is the type is person. So it will auto-convert it to an object of type person. I can also do another example here. Give me all the documents where the age is greater than 30. So I'll do find greater than, give the attribute name and the value. This will give me all the documents where the age is greater than 30. And by the way, this results inside it, I'll get objects of type person. Yeah. So in here, this is a new feature. Those of you maybe not familiar with it, this is a new feature in Java. I don't need to repeat myself and say, oh, by the way, person is the type person. If I just, this is called type inferencing, I just put var. And it will know that this is person. You see here, for example, in here, I know that this get collection will return me Mongo collection of type person. I don't need to specify this type if I wish not to specify it. I can put var. No problem. Yeah. Those of you familiar with JavaScript, this is already available in JavaScript. JavaScript is typeless, is dynamically typed. There is type, but it is implicit. Once you assign a value to a variable, the runtime will work out the type of the variable based on the value that you assign. It's kind of similar thing in Java, but you can only do it when on the right side I already know the type. I know that get database will give me back a MongoDB database. It will not give me anything other than this. I can replace this instead of repeating myself. I can just say var. Yeah. This becomes very useful in a list like this. In here, I don't need to put person as a data type, although I can. I know that results that are coming back from the query are of type person, so I can just put var here. So this is an improvement that has been introduced lately, I think in version 11 or something. Okay, here is another example. Give me all the people living in Doha. No, we already seen this. Let me show you another one. Updates. Update 1. I want you to go ahead and get me update the documents where the name is this one, Ali Falah, and combine. Yes, combine means I'll be setting two attributes, changing two attributes. I'll be changing the age. I'll be changing what? Here it is, update 1. I'll be changing the age to 23 and changing the name to this name. Okay. So in Java, the query and the updates the syntax is a little bit more verbose, more a little bit not as elegant as the native one, but it is equivalent. You can see here when I do an update. When I do an update, I first query the documents that will be subject to update, filter them. So only the documents where the name is Ali Faleh will be changed. And what change I will be doing to these documents? Changing the age and setting the name. That's what I'll be doing. Okay. In here, what I'll be doing is updating. In here, I'm updating one. I only update one document, the first one that matches this condition. In here, I'll be updating all documents meeting this condition. So here, update all the collection where I think there's a problem here. Not city, because the collection does not have a city. It should be address.city, and then I'll go ahead and update address.city. Okay. So just imagining if keep expanding, Doha keep expanding, and then all other cities will become Doha. So we'll change everything to be Doha. Anything not equal to Doha we'll change it to Doha. Okay. That is for update one and update many. And the last one I want to show you is replace. In replace, I'll say, go to this collection and find out the documents having this name and replace it with this new object. Replace it totally with a new object. And every time I do an update or replace, I can get how many documents were affected by going to update result.getModified count. I can also delete here, delete one, and deleting all the entries where the city is Doha. And here it will delete only one. Here delete many, I delete all. Where the city is Doha, I go ahead and delete it. Finally, I can drop the whole database and close the client. Okay. So let me just comment this because I don't want to delete everything, and just run it again. Here it is. No, I don't want to delete. Maybe delete one is fine. Okay, so even if I go ahead here and delete the whole database, yeah, so database will be deleted. If I run it again, it should recreate the database. Yeah, these are just information coming from the driver. So you can see here, if I go to my Mongo, refresh, I should see the database back again. And here is the people collection. And these are the data that was added, the documents that were added. Here is the address, the city, the streets, the name, and so on. And you can see here, all the addresses has been changed to Doha. The city has been changed to Doha. Although I inserted 4, I deleted 1, so 3 are remaining. Okay, so that's basically the idea. It's similar, the API. So basically, they took the native query language, and tried to translate it to an API in Java, and that's how it gets translated. It's still the same capabilities of manipulating documents, but making it kind of fade in and integrating well in Java, as if you are using normal Java. Okay. I will figure out if they have an option to just give it a string as the query. Most likely they will have, where if I have a complex query, I can test it and I write it in, let's say, in Compass, in MongoDB, and then take it as a string and just get Java to execute it and give me back the results. Most likely this is supported. In JavaScript, there are many libraries to interact between JavaScript and MongoDB. One of the famous one is called Mongoose. It has this ability. You can pass a string as a query and just execute it without using this native kind of this API, Java API. I figured it out. The example I'll be posting will have much more features. Okay, so let's go back to the slide. Any question on this? Yes, please.
What if you want to change based on multiple conditions? So if you want to replace, for example, based on
Yes.
the equality is more than one.
Yeah, I think you will do something like and. Yeah, will be something like this. Yeah, and let's say equal. It's a little bit, most likely it will be something like this. Yeah, something similar. Yeah, all the capabilities that you have in the native query, it has been exposed as an API in Java API. And same thing is happening in Python, C#, .NET. But the API is slightly different from one language to another. But hopefully they support the native one, because sometimes if you don't want to get annoyed with all this, for example, in here, you just pass string that has the condition similar to the way we write it in the native MongoDB. That will be nice, but I will explore it. Any other question? Okay, so let's quickly now just jump in here and talk about the modeling. So this, I already explained that in a document, the attributes or properties in the document, they could be a simple type, like a string, a number, geolocation, which is an array here in this case. It could be an array of objects, and it could be a subdocument. It could be a simple array of strings. So the value of properties of a document could be varied from simple types to arrays to objects to an array of objects. So what we see here, you can think of these as embedded documents, subdocuments embedded in this main document. So this is one common way of doing it, but it's not the only way. There are other ways of doing it. So modeling the relationship between collections when you have multiple collections is very important, still important as it is in the relational world. In the relational database, we use primary keys and foreign key relationships to establish relationships between tables. Now, in the MongoDB, we basically have two options. When we have documents with subdocuments embedded in them, we have two options when we want to establish relationships between documents. Either we can embed document in another document, or we can reference it, just have a link to it. So this will become clearer through an example. And the way to decide this will be based on the data itself and how it is queried, how the data is used, how the data is queried, and the size of the document. Because the maximum document size in MongoDB, I have to verify this in the latest version, but last time I verified, 16 megabytes per document. So if you have, for example, let's say customer and orders, and customer can have hundreds of orders or thousands of orders. If you decide to embed orders in the documents, documents in the customer document, you need to be aware of this limitation. Otherwise, it's better to just keep orders in a separate collection. So you have a customer collection and you have orders collection. So you need to make that choice based on the way you query this data and the data size, because there is a limit on what the document size in MongoDB.
If we make it separate, then how we will join?
There is no join, but you do multiple queries. I will show you examples shortly between the difference between embedded versus referenced. So referenced is similar to what we do in a relational database. We just kind of replicate the foreign key in the one-side table. Yeah. The foreign key, the foreign key in the many side. For example, if I have customer and orders, they are separate collections. In the order, I might have a customer ID, and a customer ID is referring to the document collection. Now, if I want to get the customer details for that particular order, I have to do another query. So there is no concept of real join as we familiar with them in MongoDB, in a relational database. In MongoDB, collections are separate. But as programmers, we can make some of the columns refer to a document in another collection. So let me show you some examples. So first of all, referencing, as I just explained, is very similar to having foreign key in the many side table. But there is no enforcement by the database. So in a relational database, if I have an order table and a customer table, and if I try to insert an order for a customer that does not exist, where the order ID where the customer ID in the order, it does not exist in the customer table, that insert will fail. Yeah, because you will have what we call an orphan record, a record that is not related to any customer, an order without knowing who the customer is. On MongoDB, you are on your own as developers. The database will not enforce anything. Yeah, if you insert an order for a customer where the ID of the customer does not exist in the customer collection, it is your problem, not the database problem. So there is no enforcement. Embedding this is what embedding is. You put the actual document inside the main document, not in a separate collection, and you just refer to it. Here is an example. So in here I have a user document, and the user has an underscore ID, as you can see here, and a username. And this user has a contact and has access privileges. So contact again has its own ID. And how do I specify that this contact belongs to this user? By having an attribute user ID, and the value of this attribute will be the ID of the user in the user collection. So exactly the same as in a relational, except here, no enforcement. If you put something here that does not exist in user, it's your problem. Okay. Same thing here. This is access, and I want to say, okay, this user have access level 5, and he's in group dev. He's among the developers group. So I basically link the two by assigning the ID of this user document to the user underscore ID. Again, no enforcement. Okay. So in here, if I want to, for example, if I want to get a user with the contact plus the privilege they have or the access they have, I have to do 3 queries to 3 collections. Exactly similar to the relational model. Now, in embedding, I take the documents and just put it as part of the main document. So the user document will have an attribute contact, and I embed the whole contact document inside the user document. And I have another attribute access, and I put the access sub-document inside the main user document. Okay, so this is then normalized in all the data is stored in one collection. So in here there is a trade-off between embedding and referencing. So we need to be aware of the advantages and limitations of each one. So with embedding, the advantage is you are basically retrieving, in this case, for example, a user, all the user and the contact and the privileges, the access privileges in one read. And you can also update them in one write. So that is the advantage, retrieving all relevant information in a single query. And you get one document that has all the details. You have avoiding implementing joins in your application. In this scenario, if you do it this way, you will do three finds. One find to get the user, then one find to get the contact, and another one to get the access. So putting embedding will avoid these multiple queries. And updating also can be done in one operation, in one atomic operation. The limit here is that if your subdocuments is an array and you keep adding to that array, such as customer and orders, you might hit the limit of 16 megabytes per document. And also, the reading, you might be reading lots of details that you might not need. That is the disadvantage of embedding. So versus referencing. So referencing, you basically have smaller document and less likely that you hit the limit per document. And also the data that you're not accessing frequently, infrequently, you don't access, very rarely you access it, you don't need to get it every time. So you're saving bandwidth, you're saving data that the quantity of data that you are bringing back from the database.
So it's like join, join table.
But we don't have any capability of explicitly doing join. The join is done kind of in the application itself. So as we saw, the capabilities that we saw so far, we only had find, insert, update. There's no join. So if my data is scattered in multiple collections, I will do multiple finds, which means multiple reads to get the data that I'm looking for. Yeah. Okay. Okay. So to retrieve the data, I might need 2 or more queries, and if I want to update, I can also do 2 or more queries. This is not accurate. Currently, in the new version 4.2 and above, I can have multiple updates and multiple inserts into a transaction. And I can make them all, if one of them fail, I can undo all the changes. Yeah? So before 4.2, there is no transaction that can span multiple collections. But now you can have a transaction that can span multiple collections. So this is not really a problem anymore. But the referencing, basically when you use referencing, you will be running multiple queries to get the data that you want. So let's look at some examples. So here is an example. There is a medical procedure. These are the details of the medical procedure and where it was done. And this is the result of that procedure. It's a one-to-one relationship. And this is a weak entity. This result do not make sense except for this particular procedure. So it's better to just embed it. This is a clear case. No data duplication will be introduced by embedding. And this data will not grow. We will not be adding more results, or even if we change the results, not much growth will happen. So this is a clear case for embedding. When you have a one-to-one relationship and basically there is no opportunity of illimited growth or unpredictable growth of this sub-collection or sub-document, then embedding is the best. So let's take a look at another one. When I have a one-to-many relationship, so in here I have the choice between embedding versus referencing. So for example, here I have a patient. This is the patient details, and then they do some procedures in the hospital. Let's say they do CAT scan and they do blood test. So I can either put these procedures as sub-documents in the patient document. So this way, when I get the patient, I get all the procedures. When I want to update, I go to particular patient, go to the procedures and insert a procedure in there. So in here, if we have a limited number of procedures, then embed, and we will not likely to hit the limit of 16 megabyte, then maybe embedding could be okay. If the one-to-many and the many is not huge and it's kind of reasonable number of entries, then it's fine to put embedding. But if we are expecting kind of unbounded number of entries that will be in here, then it's safer to put referencing. Because if, let's say, an order, a customer, an order is very hard to put kind of a limit. We might receive so many orders from the same customer. So embedding in this case might not be the optimal way of doing it, because there is the likelihood of growth of the orders attributes is high, and we might hit the limit. Okay, and also when we get a customer, not necessarily we are interested to get all the orders they did 10 years ago. It's not very interesting. Most likely we are only focusing on the pending orders. Once we finish and dispatch and we get our payments, most likely we don't care too much about those orders. So it's better to put them separate. But maybe in the case of the patient, most likely they will not do so many, hopefully they will not do so many procedures. And most likely when the doctor gets the patient record, in most cases they are interested to see what procedures they have done before. It's nice to keep everything in one file. So this is the design if you do embedding. If you do referencing, then the procedure becomes an array of IDs. And those IDs will be the document ID of the actual procedures. So this is the referencing versus the embedding. So in a one-to-many, when do you embed? You embed when you have one-to-few, customer to addresses. They will not have thousands of addresses. Few addresses, 10, 5, 6. Even if they move so many times, it's fine. I don't think they will get, it's not something unbounded. And if you often require them updated together. So most likely when the user updates their details, maybe they will update their address as well. So it's better to keep it together. Maybe when I update the patient, I will may add a procedure to their file. So most likely they will be updated together. So another reason why we might use embedding, if you want to access, it is unlikely to access the subdocuments independently. For example, order and order items. Unlikely that you will just access the order items without accessing the order. So this is a clear case. The order items should be embedded in the order, because when you get the order, you want, in 90% of cases, you want to get all the items. And if you update an order, you update the order plus the items. So for example, order item is most likely, embedding is much better. Plus it's not unbounded. People will keep putting in this cart, in the shopping cart. At the end, they will get tired and go for checkout. 100 of items, 50, not too many. Yeah. So when we have one-to-few, then it's fine to do embedding. And if this embedding does not introduce a lot of duplication, then you can go for it. You can tolerate few duplications, it is fine. When you have one-to-large, such as customer and orders, book and reviews, videos and comments, then in here it is clear case for referencing, one-to-large number of related items. So when the related data changes frequently, so for example, the view and the view count, video count, so the video metadata does not change much, but maybe the views change very often. The rate of change is very, very different. So the ones that change more often, you might put them in separate collection than the ones that are stable and don't change much. Reference entities that used in many others. For example, if you have a session and a room, it's not a good idea to embed the room in the session, because room is used in many sessions. So if you want to change the room details, you have to change it in many sessions. So for example, if you want to describe this room, the room number, what type of room, it is flat or it is like amphitheater, how many seats, and so on. So if you embed it and this room happens to have some changes, and there are many sections, course sections being delivered in this room, then you have to go and change the room details in all those sections. So in this scenario, it's better to have it referenced. But if the embedded document change infrequently, very stable information, very unlikely to change, you may go for embedding. Definitely sub-documents that are large and likely to grow and go beyond 16 meg, better to go for referencing rather than embedding. Okay. Here is another example. One-to-many, one-to-one, or even, sorry, one-to-many, which is a person and address. This is clear case for embedding. There's no need to do referencing here. Plus, this addresses most likely only belong to this person. Even if they belong to somebody else, their brother or sister living in the same place, it doesn't matter. It will be duplicated, who cares? But this is more convenient to just embed. Okay, because it is one to few. Yes, please.
I have a question
Yes.
for slide 51.
For slide, which one?
51.
51, yes.
Here in the referencing,
Yes.
you are putting the ID of procedures
Yes.
in patients.
In patients, yes.
Okay, so for example, if I want to delete a procedure, I will delete it from the procedures
Yes.
and update to the procedures list,
Yes.
or it will be automatically deleted?
No, there's no automatic. As I told you, the database is not aware of this whatsoever, and it doesn't care at all. The database, the document is black box. It's a key and value. It doesn't really care. The only thing it cares about, if you want to create some index on some column, for example, then it will start a little bit caring about that particular column to create a meaningful index. Other than this, it is you and your documents. You are responsible of doing it the right way.
So each time a procedure is inserted, I have to update the list.
Yes, in this scenario, yes. Yeah. In this design. Yeah. You might do it another way, where in the procedure, you put the patient's ID. That's another design. Maybe it's even better design. But in here, I just wanted to give you an example, like to show you clearly embedding versus referencing. And this is not the only design. It can be done other ways. Okay, here is another example here. So what I have here, person or user and tasks. So if we have in an organization and people get tasks to do, and these tasks are really one-to-many. They keep coming. We finish one and 10 come. So this is a clear case for referencing rather than embedding. Okay. Book to publisher. Book has one publisher, so we can put. So in this case, in the book we can put the publisher. No problem. We can embed the publisher if we wish. But publisher and books, because the books publisher can publish so many books, so embedding will not be the optimum. So it's better to have a publisher collection and a book collection separate. Okay. So referencing is much better. Okay. One-to-many, you will face the same thing with one-to-many, with many-to-many. So here is an example of many-to-many. So what I have here, let's say physicians or doctors working at hospitals, they work in multiple hospitals, and hospitals employ multiple let's say, physicians. So what we have here, if we go with embedding, we will create some data duplication. So this is the, what is this? This is the hospital, and these are the physicians working in this hospital. So I have, this is the first physician, and this is the second physician. If I go to another instance, and if this person is working in both hospitals, I will get data duplication if I go for embedding. Yeah. If this information is stable and it doesn't change much, you could tolerate it. But if it is very dynamic and a lot of changes occurs, then this duplication will cost you moving forward. It will create some inconsistencies, updated in one collection and not, in one instance and not updated in another one. So you need to be careful if the embedding will create duplication of data that is likely to change and often change. So embedding might not be the optimal option. Okay. So instead, you may go for referencing. So you see here, this is the hospitals. And in physicians, instead of embedding them, I just add the IDs of the physicians. And this is in the second hospital, I add the IDs of the physicians. And the same thing I can do on the physician side. I could embed the hospital here. It could be okay to embed hospitals because the details do not change much. I don't think the hospital will move, very unlikely. So you could embed, or you could reference it, is also fine. In referencing, this is how it looks like. Hospitals will be an array of IDs, and these IDs referring back to the hospitals. Now, this referencing database, as I said many times, is not helping you whatsoever. It's you as developer, you need to take care of it. Even when you want to query, you get, let's say you get the physician. If you want the hospitals, you have to do two queries. In this scenario, you have to do two queries. Not two queries, one query. Say, give me all the hospitals where the hospital ID in 1 and 2. So you get the hospitals, okay? All right, one last one. This is very, very important, by the way. This is important. This is an important pattern called bucket pattern. Now imagine you have sensors as an example. And these sensors, let's say temperature sensors or level sensors or some kind of sensor, and they are pushing some data to your database. Imagine that for each sensor, you create a document, and then you keep appending to that document the measurements or the reading coming from the sensor. What will happen to this document? It will grow, and most likely it will hit the limit. Plus, basically, your documents will be very large. Even if it doesn't hit the limit, your documents will be very large when you read them. So instead, what you could do is you do what is known as bucketing pattern. Instead of creating one document per sensor, you create multiple documents per sensor, and you bucket them. You say, okay, I'll create one document per sensor per day or per hour, depending on the frequency of data that is coming. So, for example, in here, this is the daily bucket. I could decide to do a daily bucket. Every day, at the end of 24 hours, I create a new document. And this document will have the sensor details and the measurements. And then at the end of the day, I create another document. So in this case, it's much more manageable. So I will get multiple instances of the same sensor. Yeah, with the bucketed in terms of day. If I am finding myself, these sensors are pushing lots of information to me, and even bucketing at the day level is still creating large documents, I can shrink the bucketing scope, make it hourly, or make it a couple of hours. Every couple of hours, new documents get created. So this bucketing could be very, very useful. So even for orders, remember we said customers have orders? You could do the bucketing design. where you have customer and you have orders. And these orders, you might have a customer instance every, let's say depending on the frequency, every month or every year. Let's say every year you have a new document for that particular customer. That is the bucketing pattern. So it allows you to keep the embedding. That's the advantage of it. But this embedding is also kind of partitioned across time. Yeah. So it's giving you, it's balancing. It's still giving you the advantage of embedding, but helping you to avoid the limitation, the 16 megabyte limitation, and also helping you not to let your documents grow exponentially. So keep this in mind in your design. Last one, sorry, I'm keeping you a little bit, give me 5 minutes. I just want to show you one very important query capability you will need in your project, which are the aggregate queries, summary queries. All of you have reports that you need to produce. So MongoDB has a very powerful query mechanism for aggregating using pipeline. So those are familiar with Unix, you can pipeline commands. So in a similar fashion, you can do, for example, here I go to orders, here's my collection orders, and I want to aggregate. So I use this function aggregate, and then first I do match, and then I do group by. In match, I say, okay, only give me the orders where status is A. Then I want you to go and group by customer ID, and I want you to do this, to do the sum of the amount of each order. So this will produce for each customer what is the total amount per customer. So this is done in phases. So first I do the matching. I get an intermediate result of the match, then get this intermediate result and put it through the grouping, and I get the final results. So let me show you some small examples here. So here, what I have here, I have some, let's say, some orders here. So what I'm doing here, I will go ahead and aggregate. I group by the month, the day, and the year. Then what I'll be doing, I'll do the sum. I'll do the sum of the multiplication of price times the quantity. Also, I will do the average of quantity. So the result here, I will have for each day, what is the sum of the amount of order and what is the quantity that was ordered, the average quantity that was ordered. Let me show you another example here. Yep. So if I want to get the states, the US states that have a population greater than 1 million, or 10 million, sorry. So what I can do here, this is my collection. I say, go ahead and aggregate this collection. I want you to only focus on the states where the country is USA. And I want you to group those documents based on the state. And I want you to compute the total population per state. Once you do all of this, only return me the states that have more than 10 million, the population is greater than 10 million, okay? So you have multi-stages, and this tool can help you do this, like this aggregation here. So for example, in here, I can do here match. And I'll put here, let's say, age greater than or equal 20. Yep. I already filtered, yeah, by age. I can add another one. Yeah, I can add another one and say group by group. And I will say here, grouping is, I'm grouping by what the, I think I can put null. So I want to group all of them. This is average age. And here, this is average. And this is age. Yep. Okay. So what I mean, the first stage will be filtering only the people with the age greater than 10. The second step will be grouping them. Here I put null, or I put, well, let me put, let's say, address dot city, average age, expected motivation, but this. Anyway, you can use, I haven't been playing too much with this, you can use this aggregation aggregation editor in this Compass tool to help you build such aggregation and test one phase at a time and then connect those phases. That's it. One, here is the last one. Aggregates, I'm aggregating student collection. And group by, if I put here the ID null, means group all the students, and I want you to give me the average GPA. I put $average, $GPA. This is the name of the attributes I am summarizing, doing the average. In here, I'm grouping by student's ID. Yes, grouping by student's ID, and computing the sum of the hours, the course hours completed. And this will be completed credit hours. So I will get students' IDs and their completed hours. Yeah. So that's the idea. And I can put, for example, match where program equals CS. I can do this. So it's a multi-stage aggregation framework, very, very powerful to allow you to create aggregates for your reports. And because most of you in the projects, there is a report. In the program I will be giving you, in the example I will be giving you, it will have some concrete examples. And by the way, in Java, you can also do the aggregation. You can see here, I gave you some example here. So what I can do here, here is the aggregation. Here is an example aggregation. So I'm saying aggregate match. I want you to only give me the restaurants with the bakery category, and I want you to get the sum of their stars. Yeah. So it's a bit not so intuitive, but that similar when they try to translate those phases into Java API, it gets a little bit not so, a bit complicated, but I think through some examples you will make it. Okay. All right, I think that's the time we have. Thank you very much. Inshallah, next time.